Hey, folks, we're going to be talking about basic area today in section one, chapter six. The whole chapter is about area and volume. And some of it's real basic, like what's the area of a rectangle? What's the area of a triangle? It goes as far back as that. It's important that we have those basic skills. And sometimes when we're talking that basic, we're like, well, how could that ever apply to my life? Well, home ownership is one of the ways that you can increase your wealth when you get older. It's one of the best investments that you can make, and it is full of geometry with just basic area. You know, like if you're going to paint your house, how many square feet are on the exterior of your home? You know, how many square feet are you going to paint? You've got the yard. How many acres do you own, or you know, um, how many square feet of grass seed do you need? I mean, it is endless the amount of calculation with area that you'll do. That's just one example, but really, you know, it's more about us improving our deductive reasoning skills than anything else right now. So this is a good opportunity to kind of refresh some of our knowledge with Pythagorean theorem, with trigonometry, you know, sine, cosine, tangent, and we're going to see those concepts pop up. I don't want them to intimidate you. I know you can do this stuff. Take good notes, ask lots of questions, try all the homework problems. You're going to be just fine. All right. So let's just talk about basic area for just 1 second. Please, you know, put the video on pause, structure your notes like this. We have parallelogram, trapezoid, kite, and rhombus that we're going to talk about today. But they all kind of rest on us understanding a basic rectangle and a triangle. So if we're going to find the area of a rectangle, you could say, well, I'm going to measure how long this length is. Okay. So let's say this length comes out to be 6 feet long. All right. And let's say this length over here comes out to be 2 feet long. All right. So what does that mean? That means that we had 1 foot right here, like a one there and a one there, right? And if we had six coming across here, well, let's see if I can divide that up into six parts. Okay, you have right in the middle, then you'd have one over here, you'd have one right there, right? You'd have one right here, you'd have another one right there. So how many squares do we have in here? Well, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 square feet. 12 square feet. Now, I'm not trying to insult your intelligence, but that's why the units come out to be square feet or square inches or square centimeters. Whatever the units are, when you're talking area, you have square feet because that's how many squares fit into that shape. Now, sometimes people get a little baffled when we don't have something that you could have perfect squares in, you know, like how are you going to divide these up into squares? And, you know, we only have so much time. I want to keep these videos to about 5 minutes long. So I'm not going to go into great detail on everything about this, but hopefully you remember that there are some formulas that we can follow, right? So like we don't have to divide things up into squares. Like the formula for a rectangle is length times width or base times height, right? So the area is base times height or length times width. Well, this could be called the base right here. This could be called the height right here, right? And 6 times 2 gives us 12, right? 6 times 2 equals 12. So how do we deal with this guy right here? Well, this is the height. Just like this went perpendicular, this height went perpendicular between the bases. This is my height right here. And then this length down here is my base. And a triangle is half of a rectangle. So if you had a rectangle here, I'm not going to draw it in because it might clutter up my picture. But if you had a rectangle, here's the base, here's the height. The area would just be base times height. But a triangle is actually half of the rectangle. So the area formula for the triangle, 1/2 base times height. Okay, we're to the new shape. Maybe you know this one already, and I've wasted your time on video one. But our parallelogram really is a rectangle if you take one side over here and let's say we cut this triangle off right here. In fact, I'm gonna grab my triangle tool and I'm gonna draw a triangle right here. Okay. And let's say I took that triangle and I slid it to the other side. So I'm going to take this triangle here, I'm going to slide it to the other side of my parallelogram. Now let me kind of highlight this in red. So what do we have? We have this side right here. We have this side coming over here, and we have the rest of our rectangle. So what is the area formula of a rectangle? Well, it's the height over here times the base over here, or the base down here. It doesn't really matter. The base over there, right? So this rectangle right here has an area of base times height, but really that's the parallelogram. That's the area of the parallelogram. It's just that this triangle right here is right over here. Like if I shade this in blue, this wouldn't be here, this blue triangle, because we cut it off and we put it over there, right? So the area formula for the parallelogram is going to be just base times height. So the first problem you see, before you shut the video off and try problem number 1, the first problem is a parallelogram. Let me go back to my parallelogram tool here. It's right there. And it's kind of oriented. Oh boy, I hope I can get the orientation right here, like that. And it says that this side over here is 12, and it says this side right here, it's not really a side, it's the height. This is 9, so this is the height. This is the base. The area is 9 times 12. Go ahead and do that on Desmos or in your head, and then type it into McGraw-Hill and try it out. The first 4 problems are parallelograms. Okay. Now, you are going to run into situations where you're not just flat out given the height and the base. You will have to determine that, based on a 45-degree angle or a 30, 60, 90 triangle. And that's where the challenge is really going to come into play, right? So like if you weren't given this 9 right here, let me just erase that for just a second. If you weren't given that 9, then, so let me cross that off. It doesn't like when I do that. Let's say you weren't given that information, but you were told this is a 60-degree angle right here. And let's say they told me that this side right down here was like 3 long, okay? Well, if that's 3, then this side right over here is 3 square root of 3. Remember how you multiply by the square root of 3 to get over to here? Or you could do the tangent of 60 degrees is equal to x opposite leg over the adjacent leg, and you could go 3 times the tangent of 60. This is where people are really going to struggle a little bit. I don't think you're going to struggle just using the area formula if they were giving you the base like 9 and 12. It's going to be a little more challenging when they don't give you the height or they don't give you the base, and you've got to use some deductive reasoning to figure that out. Hey, thanks for watching my video. Good luck with your homework. Ask me lots of questions during class.